In this last section of the course, we'll be talking about income flow. It's an application of integrals, and it's a nice way to finish. So let me remind you first of what you've learned twice now, once with differential equation and once in the quiz with the history of E. So if P dollars is invested at a continuously compounded interest rate of R, then after T years, you will have Y of T, which is P e to the R T dollars. Alright, so now the setup is slightly different. In this setup, you take your P dollars, you put them in the bank, you sit back, you relax, you don't do anything, you don't put more money, you don't take money out. In the new setup, money will come in non-stop. Alright, so here's the setup for money flow. So it's usually better for a company. You assume that a company for a certain period of time, so during T years, a company receives money continuously. So every fraction of every minute of every second, every fraction of time, money is coming in. Okay, so receives money continuously. And as soon as it comes in, the company takes the money and puts it in an account where interest is compounded continuously at this interest rate. So, and invests it all at a continuously compounded interest rate of R. And in general, we'll ask three different questions. The first one is how much money did the company receive and how much money did it invest? So how much money, just capital, was invested. Second, how much money will they have at the end of the T year? So that's capital plus all the interest that's been accrued. And an interesting question is if you had to buy this investment today, how much would that be worth? So we'll ask total money flow, that's how much money capital is invested, period. Future value, how much money is in the account T years from now. And present value, how much is this worth today? All right, so let me define all three. And then we'll do a simple example of just picking out of a word problem where the different values are given. And then we'll start involving integrals afterwards. So here are the three definitions that we care about. So first, the total money flow of this investment. That's the amount of money coming in and being invested. So that's capital, is the total amount being invested. So this is how much much money would be in the company's pocket after T years if instead of investing it, it just kept it in a sock under their bed. All right, so that's the total money flow. Second, we have the future value. So the future value, which I'll denote as FV, of this investment that's how much will be in the account in 10 years. In 2 years, sorry, I keep saying 10. In is the amount in the account in 2 years. All right, so that means capital plus interest. Well, this is capital only. All right, and the final one is present value. When I said present value is how much that investment is worth today, let me make it as precise as possible. So the present value of this investment is how much I would have to put in an account today and then sit back and do nothing to ensure that in T years I have exactly the same amount, this future value, as the investment of the company. So the present value of this investment is the amount that one should invest today at the same interest rate. So we're assuming that we have access to the same interest rate as the company, should invest today at a continuously compounded interest of R to end up with FV in T years. All right, so that's the present